Today we're going to be looking at domain and range of functions, specifically the domain and range of a function when given a graph. So over the past day or two, we've been talking about domain and range given a table or given a list of ordered pairs. Today we're going to be focusing just on graphs. Domain and range of graphs. If you'll remember from yesterday, when we talked about domain, the variable that should come to mind is x. So when we look at the domain and range on a graph, when we look at the domain on a graph, we're focusing in on what these x values can be. So the domain is all the possible x values that a graph can take on. If we're looking for it on a graph, you're going to look at the x-axis and you're going to put the smallest x value on the left of your inequality and the largest x value that the graph reaches on the right. In the middle, you'll put x. So this is saying x, the x's are smaller than whatever your largest x value is, but they are larger than whatever your smallest x value is. Visually, if you're looking at that on a coordinate plane like the one above, the smallest x is going to be the x value that is the farthest left. So this is the farthest left x value that the graph touches, and then the largest x value is the farthest right x value. We'll break that apart in a minute. Let's go and look at range. Now you'll remember if you're looking at the range, you're looking at the possible y values that the graph takes on. So that is why in our inequality here, when we state the range, we're going to be focusing in on the y values. On a coordinate plane, the y values are found on that vertical axis. So now when we find the range, we're finding all the possible y values on that vertical axis that the graph touches. If we want to find it, find the range, you look for the smallest y value, and you look for the largest y value that the graph touches. This inequality is stating the y's must be in between, they must be smaller, less than, the largest y value, but greater than, on the bigger side of, the smallest y value. Visually, on a graph, to find the smallest y value, it's going to be the lowest. So you'll look for the lowest y value and compare it to the highest, how high the graph gets, the highest y value. And that's what we're going to be really focusing on today. It's just breaking apart that domain and range. Now, a couple tidbits before we get going any further. You'll notice that sometimes you might use the less than versus the less than or equal to sign. So zoom in on this versus this. You will use the less than sign or greater than if your graph is approaching infinity or negative infinity. We'll talk about that more later, but those are going to look like arrows on the end of your graph. And you'll use a less than sign with no bar underneath if you have open circles. On the other hand, you will include a line underneath if your points that the graph reaches are solid. We'll focus more on this in the examples that come ahead. But remember, if it's an open circle or if a graph is approaching infinity or negative infinity, there is no line underneath our inequality signs. Let's check out our first example. The first thing we're going to find is the domain of this graph. You'll remember that the domain is associated with the x values. I would always start by writing an inequality here. We know it's dealing with x because we're talking about domain, and then surround it with your less than signs. Remember, we're putting the smallest x on the left and the largest on the right. That order matters. So smallest x value that the graph can be on the left, largest x value that the graph can be on the right. If you have a highlighter at home, I would take your highlighter out and highlight with me. If we're finding the domain, we're trying to look at the x-axis and find the smallest x value that the graph takes on. So I'm going to go all the way to the left over here, where it starts at -3. And I'm going to highlight until the graph stops. So it includes all these x values and it stops right there. You'll notice on the x-axis that graph starts at -3. On the x-axis, it ends at +1. The last thing we need to take into account here is whether those inequality signs should have a bar underneath them or not. When you look at -3, you'll notice that it has an open circle. That means that it reaches that number but does not include it. So we will leave it as just less than. When it gets to 1, on the other hand, you'll notice that it's a solid bubble. Since it's a solid point, it includes it, so it gets all the way to 1 and includes that 1. So our domain is all the x values that are in between -3 to +1. Let's do the same thing with the range. Get a different highlighter color, and when we're talking about the range, we're talking about y values. So we're going to still set up our inequality, but we're going to put y in between. We'll worry about whether these should have lines underneath them, these inequality signs should have y's underneath them in just a minute. Remember, we put the smallest on the left, the smallest y value that the graph takes on the left-hand side, and the largest on the right. The y-axis is the one that goes up and down, the vertical axis. So go to the lowest part of your graph and highlight to where the graph stops on the y-axis. That's that purple highlight. The smallest value that the graph takes on in terms of y's is -4. The largest value that the y's takes on is 0. At -4, we see a solid point, but we also see a location over here. When the graph just touches it and bounces away, we can assume that is including it, so we put a line underneath it. So it includes -4. On the other hand, as you go up the graph and look all the way to 0, you'll notice that we have an open point on the left, but because this is a solid point, it hits that 0, it includes it. So we can say that it also includes 0. So this range is saying that the y's can be any y values in between -4 and 0. Let's try another example. Keep those highlighters handy. Domain, we're looking at the x-axis, so set up your inequality. Remember, smallest x on left up to the largest x on the right. Take your highlighter and look only at the x-axis. So we start over here, travel all the way to the right. If you look at that x-axis, you can just zoom in on the number line. The smallest x value that the graph takes on looks like is -8, and the largest over here is +6. Because the line touches those endpoints, we would put a line underneath. We'll do the same thing with the range, except you need to put a y in the middle of your inequality. Remember, it's the smallest or the farthest down y value on the left and the largest on the right. Get your calculator, not calculator, your highlighter handy. Go from the lowest part of the graph up to the highest part of the graph and use your highlighter just to highlight along that y-axis. The lowest y value is right here. What is that y value down there? Looks like -5. And it goes all the way up to this y value, which is +9. Because the line touches at those points, we would put a line underneath. So on this circle graph, the y's include everything in between -5 and +9, inclusive, meaning it includes those endpoints. Let's move over to the back and practice some more. I would encourage you to continue using your highlighters to help you out visually. So we're going to set up our inequality for the domain. Then get your highlighter out and look at the x-axis. Now, something different happens on this graph. You'll notice that there's an arrow on the end. That arrow means that this graph is going to continue forever and ever to the left. Same with the right-hand side. So if we're trying to figure out, if we're trying to highlight the x-axis, where this x-axis starts, it goes forever to the left. If we go to the right, we'll see an arrow saying it's going forever to the right, so it will continue on. This is a unique scenario that I referenced on the front. Because the x has no stopping point, we say it goes forever into the negative numbers. Forever into the negative numbers, we say in math, is negative infinity. On the right-hand side of the graph, because it goes forever and ever to the right, with all those positive x values included, we say it goes toward positive infinity. So this graph has no end in terms of its x values. It includes everything from negative infinity to positive infinity. When we write negative infinity and positive infinity in an inequality, we do not use a line underneath because you can't include infinity or negative infinity. On the other hand, the range, let's set up our inequality. We have y's that we're looking at now. Go to the lowest part of the graph. Start highlighting your y-axis there. So our lowest part starts here, and similarly, it continues up and up and up and up forever and ever. So when we're talking about our range, the lowest value that the graph took on was right here at -3, and then it went up forever. Up to these positive numbers forever and ever is called positive infinity. Just like with the one before, we do not include a line underneath, but with this -3, because it hits the -3 right there, we would include a line underneath. Let's continue on with this next example. Set up your domain inequality. Just like before, we're looking at the x-axis to find our domain. Now, if we're looking at our x-axis and we look over here at -8, look down at the graph, you'll see an arrow. Now that arrow looks like it's going down, but it's also going forever to the left. So we're going to know that these x values are going to continue forever to the left side. It includes all these x values where we see the red graph. And then when we get to this, assumed endpoint of the graph, look up at that graph. It has an arrow on it. That arrow is not only going up, it's also slowly going to the right. So it will eventually include all of these x-axis values. So we would say our domain goes forever to the small x values. That is called negative infinity, no line underneath your inequality sign. It goes forever to the right, so we call that positive infinity. So just like the problem before, when it goes forever to the left and forever to the right, it goes from negative infinity to positive infinity. There are no restrictions on what x can be. Let's look at our y-axis. If we think that the graph starts right here, we look at that arrow and it's going down, so it's forever going to include those negative y values. Highlight up all the way on the y-axis till the red line stops. But when that red line stops, it has an arrow on the end, so it's continuing up and up and up. So similarly to our domain, the y values start going down forever. We call that negative infinity, and they continue up forever. We call that positive infinity. So there are no restrictions on what either the x or the y value can be. In our next example, set up your inequality for the domain, and let's highlight on the x-axis. There are no arrows on the end of either side of this graph, so we know that there's going to be some endpoints. Highlight the left-hand side of the graph all the way to the right-hand side on the x-axis. Oops. You'll notice that the graph starts at -8, and it continues to +8. Because that is not a clear open circle, we would put a line underneath. It's assumed that it's included, and it continues all the way to +8, included. Do the same thing for your y values. Set up your y inequality. Look for the smallest y value on the graph. Now, the smallest y value starts right here. Don't get confused. That's not -8 or +8. Those are x values. In terms of y's, this is 0. It includes it because it touches there, not a clear open circle. Touches it over here and over here. And then it continues all the way up until right here on the graph, which I guess we can say is about, what do y'all think? 7.5? And it includes it because it is not a clear open circle. want y'all to try this next row. Actually, let's zoom in. Just try this one. We did that one already. This one problem right here. So we're skipping the one on the left because we've already completed it. You should be trying this middle one here. When we look at our domain, we look at the farthest left that the graph goes. The smallest x value that the graph takes on is -2. It includes it. You should put a line underneath it. When we look to the right, the graph doesn't stop at these endpoints. There's arrows on the end. So it goes forever to our positive x values, which we call positive infinity. When you look at your range, make sure you're setting up your inequality with y in the middle. You'll notice that the graph, if you look at the y-axis and try to highlight, it doesn't stop at this location. It continues going right, and it also slowly is going to continue going down forever. So we should call that negative infinity. Similarly, at the top, it doesn't stop right here. It continues on and on to the right, but also up if we're looking at the y-axis. So it goes from negative infinity to positive infinity. There are no restrictions on what y can be in this graph. Even though we only get a snapshot of it, it will continue on forever down to the bottom and up to the top. Try out this one. Pause your screen, find your domain and range. If possible, make sure that you're using those highlighters to help you visually see what your X is stuck in between and what your Y is stuck in between, and you can highlight your X and Y axis nice and clearly. This stuff is so visual. The more color you can add, the more helpful it'll be for you as you figure this stuff out. On your X axis, the graph ends here. That X value is -3. Because it is a solid dot, you should have included a line underneath that inequality sign. As you travel to the right, it includes all these x values until it gets to +2. Because that is an open circle at +2, you should leave it as open. In terms of your y values, go to your y-axis, go to the lowest point. It's -5. There's no arrow on the end, so we can assume it stops at -5, and it includes it because it's a solid dot, so make sure that you put a line underneath that inequality sign. It continues up and up and up all the way to the top of the graph where it stops at +4. When it hits +4, it includes that point, so make sure you include a line underneath. We have one more row of examples to try. I put a lot of examples on here because domain and range can be very confusing to students, so I want y'all to get lots of practice. Pause the screen and try this one out. You should have gotten that your x's start at 0 and go all the way to +6, inclusive, meaning including the endpoints. The y values start at -6 and go all the way up to, I just estimated to 18.5. If you just said 18, I'm not very picky there, as long as you understand that they go in between -6 and +18. Pause the screen, try this guy out. When we're talking about our x values here, you'll notice that when you highlight your x-axis, it goes forever to the left. So the smallest x value is -infinity. As you look along your x-axis, it includes all these values until +4. It includes +4. Your y values, if you highlighted your y-axis, they start right here. Remember that it's a y value of 0. It includes it. And then the graph doesn't just stop where that black line stops. It has an arrow on it that goes to the left, but is also slowly going up forever and ever. So we would say it goes toward the positive infinity in terms of your y values. Last one, pause the screen, give that one a shot. On this one, You highlighted your x-axis, that's showing up as my pink, starts at an x value of 0, includes it, line underneath, travels up the way all the way to 1, 2, 3, 4, 5 in terms of your x's, does not include it, so make sure you do not put a line underneath. Your y values, you should have gotten that they started at 0 and include 0 and travel all the way up on the y-axis to 1, 2, 3, 4, 5, 6, 7. They do not include 7 because it is an open circle. Rewind and look at any of those examples that you might need to re-listen to. Your homework will be practicing that domain and range content. Please log back into office hours if you have any questions.